Hello, everybody. Let's do the chapter 2 guided practice here. You can download the file, it's going to be in your Blackboard shell, and do the same, upload it to Collab. You want to do it through there, is the way that I'm doing it. If you have your local environment, you can use your local environment too. Here we'll be focused in understanding a little bit NumPy, sorry, and how to move along with it. I will try to keep it simple, not to go to more details in there, but just to try to focus on the code itself. First, it's asking us about a list. It's a traditional Python list. So we know that for that, we just can do something like a equal 1, comma 2, 3, 4, 5, and then we can just do print a to see the content, and that's official Python list the way that we know it. Let's wait this for run. There you go. Then let's have another list. This actually should be list 1. This is the how it says over here. Let's change this to list 1 and keep it as it is. Cool. We can do a list 2. And the cool thing about Python and the list is that we can have multiple values. So we can have an integer here. We can have a string. We can have another a float, a boolean, and another integer. And if we print it, this should work. And we can see that all the contents are there. So one of the cool thing about NumPy is now we can import it and use it the way that we need to do in our application. So let's keep and see the benefits to actually use it. So let's just here just import it, import NumPy as np, remember the alias, and execute in order to make it available. And we're able to do an arrange now to have a new list or a new array from 0 to 9. Remember that this is exclusive. That means start with 0 and ends on 9. Print the array and print the shape. Let's do that. So let's do a1 equal np dot arrange. Then a1, let's do print a1, and it's print with a t. And then we can do print a1 dot shape. We will do that. Let's see. We can see that the list is there, or the array, and it gives us the size and this how many rows it has, and doesn't have columns because it's a list. That's why the second value is nothing. So we can see the whole NumPy can actually start working for us and helping us in the process of the different elements that we need. So the other part would be let's actually specify a step, and that's really simple. If we add a tier value to the range, we can like jump between one value to the other. So let's take this one, let's paste it here, call it A2. But instead of just a simple, so let's do start at 0, end at 10, and do a step of 2. And we can say 0 all the way to 8 because that's the step. Remember that the last index is exclusive. And that's another way that we can utilize this. Now let's create the array of zeros. We'll use the NP zeros here. And we say that it should have 2 rows and 3 columns. And then we can just print the shape to confirm that dimension. It should be that like that. And then we can print the actual array to see if it is what it is. So let's do A4, call it like that. And let's do np.zeros 2, comma 3. Then we can do a simple print A4.shape and as simple as print A4. If we execute, we can see the actual size and we can see here our array, multi-dimensional array with 2 rows and 3 columns, doing what it's supposed to. Cool. Now let's do a random generation. That's actually pretty cool. NP random, go to the array, and let's call it A7. We have dimension 204 because how we ask it. Print using the shape, and let's print the content of this one. So we can just do a simple A7 equal np dot random done random. Let's do 2 by 4, and let's do a simple A7 dot shape. This should be in parentheses because we need to print it. And then let's actually print our A7. Let's execute, and we can see that one is actually working. The size of the shape is correct, and we have the multiple values being part of the array. We can also convert a normal list in an NP array, and we can do that. So let's convert R1. Let's say R1 will equal np.array from our list one that we did before. And let's just print our R1 to see it's actually working. And it does. That will allow us to just get a traditional list and traditional array and not actually print those they were supposed to. A way to access those should be as simple as print through R1 0. Remember, 0 will be the label. It's not the index. It does, well, it is the index, so but by default the label of the column it will be 0. And let's do print R1 at 1, and we can see number 1 and number 2 be printed the way it's supposed to be. Now let's see the next one over here. So it says create a Python list, create 2 Python lists, list 1, list 2, each containing 5 integers. We already have those. Use np array list 1, list 2 to create to do numpy array by stacking list 1, list 2 as row. Let's do it. So let's do print the shape of R2. Okay, it doesn't specify. Yeah, it does. R2 here. So let's do a simple R2 equal np dot array, and we have list 1, list 2. Actually, before I continue, let's actually do the list, because if I remember, list 2 is a multiple type of data types it has. So let's just do another one. Let's say, I don't know, could be 0, 9, 8, 7, 6. Yeah, I think that should be it. I don't know what is happening here. Complaining. Not close. I just close it. Oh, the value need to be next to it, I think. Oh, interesting. Something's happening here. Oh, I'm missing a comma here. That's why I didn't like it. So let me just separate just to better readability. Okay. We can do the list 2, list 1, list 2. Um, it does have an issue right now. And it's telling me that NP array, oh, a common mistake. This should be inside square brackets. Okay, it's working now. Let's do uh, print the shape. Also, let's do print r2.shape, and then it says print r2 to display the content, print r2, and then I need to specify a specific value, so let's do print r2 at 0, 0, at 0, 1, and at 1, 0. We execute all those. We have the shapes 2 and 5. That's correct. 2 dimensions, 5 values. They 2 rows, 5 columns. Yeah. We see 1 to 5 and 0 to 6. 0, 0. 0, 0 is 1. 0, 1 is 2. And then 1, 0 is actually 0. Yeah. It's doing what we are selecting or making it work. So we can have some fancy indexes in NumPy. So let's access this one over here. So we have array list 1. We don't need to define it. We need to convert it to R1. I think R1 is already defined also. Let's do R1 just to verify. Yeah, it does. So we can skip that part. So let's now just print R1. And let's do, remember the double square bracket to select would be 2, 3, and 4. If we do this, we can see that we have 1 to 5, that's R1 complete, and 3, 4, 5, just the one what we selected through here. Perfect. Now, element-wise comparison in NumPy. Use the comparison operator bigger than to check its elements is greater than 20. Okay, nothing is greater than 20 at the moment. So let's change that. This will return Boolean if true. So let's do first. Um, let's do list 1 equal to 10, 20. Actually, let's do something extra here. We should be able to do one of the matrices or vectorized operations. So if we do R1 by 10, this should work. And let's do first and after print R1. Let's do this. Okay, didn't print R1 by 10 the way that I wanted to. So let me verify that part. So in theory, this actually should work. Not sure what is happening. Maybe do I need to put like a result equal, and then I print result. Yeah. Okay. So this one doesn't affect the current one, but it give it to the result. So I'm able to print it. And let's use result now as the new one. So we can actually do the Boolean comparison for bigger than 20. So let's move along to that. We can do as simple as print result bigger as 20. And we can see false, false, true, true, and true. The way that we wanted or we needed here. Cool. So we can filter elements based on a condition in NumPy. R1 bigger than 20 that creates Boolean mass in the R1 greater than 20, and then use this max to index R1 and print only the element that satisfy that particular condition. So in this case, not going to be our R1, it's going to be our result. So let's do as simple as print, and we need to print result. Yeah, it gives us everything. But let's do select from result only when result is bigger than 20. And now we have those over there. So let me just copy this over and let's remove this one. I probably can move this up. Yes. So you can see that result, it show me all of them. And when I ask only the bigger than 20, it do that masking and we can just print the one that we need. We can do the odd numbers from NumPy array. Use arrange 20 to create from 0 to 19. Use condition nums mod 2 to filter at nums array and print the inner array nums and the filter one in odd nums. So this should be really, really simple. Let's do a simple as, let's call nums. Yeah, with what they're asking us to. Let's do equal np arrange 20 and print nums. Sometimes takes longer than other times. Remember that compute times should be shared between several collabs. So, okay, we can see it's working. It's doing what it's supposed to. So we can do add nums equal the nums where nums by 2 is equal to 1. Nums is like this. And this is nums is like this. And we print add nums, we can see those right there in the bottom. They were supposed to be. So we can have that condition pointing that those nums should be there. So we are printing nums and we're printing the other ones, and those should be rely or provide us the one that we needed. So let's do the slicing part. So here is just a slice nums 1, 2 to create a new array, big one, contain elements from index 1 to index 2. It makes sense. Remember, index 3 is excluded. The element at index 3 is excluded. Print the results of array B1. So it will be as simple as B2 equal nums 1 to 3 and print B2. It's actually B1, not B2. Sorry for that. B1. And it's doing what it's supposed to. Okay. Create NumPy edges and list of edges here. So somehow the file as array has the output there and the code got deleted. So let me just copy the first one and let's do edges equal mp.array. Remember, we can do an array through here and we can say these are the values of the array. And in order to make an array, it needs to be separated by commas. Okay. Then it's telling us sorted edges. Let's take that. Sorted edges will be mp dot sort, and let's sort for edges. Let's do print edges and print sorted edges right here. And we can see that's the output. So we have multiple values and we np sort and send in the numpy array. We can sort those right away the way that it's supposed to. Now we can sort those in place too. The np array, it returns a new numpy array, but we can do the dot sort to have it right there. So we can do edges dot sort and just print edges. And now edges have the same as sorted edges. So it will depend how we want it. You do it in place or do it with a new one. So let's do another one. Getting indices of sorted elements. That's really interesting one. So we can do, let's take the original value one more time. I take this one over here, paste it. So we have edges, and we can print with the edges dot rg sort. And we can see right there, it gives us the sorting by the index. So we can see that this one is the first one, and then is the second element. Yes, it makes sense. The first one, the third one, and actually this is 13, and then 34, and then 37. So it gives us the index sorted the way it's supposed to be, and it's just a new way to get it with the arcsort value. As last one, what we need to do now is just use method for the edges. Have to have sort the edges in ascending order. Sort the indexes to reorder the names, and then the name should be array. So we need to create a couple of names out there, and we can have then the different values the way we need. So let's do mm, names. It will be mp.array, and let's use, I don't know, Joe, Jack. I'm using single quotes. We can do strings by double quotes or single quote. It really doesn't matter much. It will help us sometimes when we need to actually print the double quote without having escape character. We can just do single quote to print the double quote. So that would be a way to do it too. So let's do John, and let's do Jane there. Okay. And we have ages. So let's do print ages and print names. Names. We have an issue with names. The issue that we always forget, that's why I'm saying you need to be really careful. We need to put that inside. Okay. Yes, edges are like this. These are the one, and it's all asking us to sort the name by the edges. So we can do as simple as copy this, print names, and we can do, okay, by who, edges dot r sort. And now we see that the fourth element is first, and then the second element, Jack. Perfect. Then go back to the last one, Jill. Perfect. So John, Jack, Jane, Joe, and Jill. Um, sorry, the last one to be Jane. Sorry, yes, Jane. That's what we have here. I got missed. I'm sorry. The third one will be the first. That will be Joe. And the fourth one, that is the one in the middle, will be Jill. And that got sorted. And that way we're able to send or sort one NumPy array with the order of another one. And that will be for the guided assignment. For now, let's just finish it, print the PDF, and load it to Blackboard for the graded assignment. And I hope that you like it. Meanwhile, any question or any doubt, please don't hesitate to reach me. Happy coding, everybody.